Hello students. Today's video is titled Solving Inequalities. And we worked with inequalities in our last unit, so some of this will be familiar, some of it will be a little new. So let's get right into it. First, I wanted to share our inequality symbols. So this is like every symbol except equal to. These are the inequality symbols. So when something is not equal, you put an equal sign with this slash through it. That symbol means not equal. So if I wrote something like this, like 6 does not equal 3, that would be perfectly true because 6 does not equal 3. Less than, we've already talked about. I asked you to memorize what that symbol looks like in our last unit. So that's less than. That might be something like 5 is less than 10. True. Then we have this new one. We did not talk about this before. There is a symbol that is called less than or equal to. So it's the less than symbol, just like this, but underneath it, it has like part of an equal sign. That means less than or equal to. Now, the cool thing about that is you could still use this example, 5 is less than or equal to 10. And it's because of this or statement. 5 is not equal to 10, but it is less than. On the same token, I could write this. 5 is less than or equal to 5. See, now 5 is not less than 5, no, but 5 is equal to 5. So this symbol right here works for this statement and this statement, which is kind of cool. All right, the next symbol, greater than, you should know this one from the last unit. I asked you to memorize that symbol, greater than. 2 is greater than 1, true story. And finally, greater than or equal to. So you have this greater than with part of the equal sign underneath it. Maybe we would do something like 12 is greater than or equal to 3. That is very true because 12 is greater than 3. But I could also do 12 is greater than or equal to 12 because 12 is equal to 12. So this greater than or equal to and this less than or equal to gives us a little bit more freedom with what we can say. Okay, let's take a look at how you graph some of these on number lines. So if you take a look here at my example 1, it says x is greater than or equal to 3 means all numbers greater than or equal to 3. We can represent this on a number line. So when you see an x here, x is just holding the place for all the numbers that are greater than or equal to 3. Well, where are the numbers greater than or equal to 3 on a number line? Well, we're going to go to this 3 right here, and I'm going to put a circle right there. And I have to decide, should I color that circle in to include the 3 or not? Well, because our symbol has the equal to on it, we want all numbers greater than or equal to 3. We'll include the 3 by filling in the circle, and then we'll shade to the right because this is greater than. So that basically means anything, any number on this shading is going to make that inequality true. For example, if I use the 3, is 3 greater than or equal to 3? Yes, it's equal to. What about 4? Is 4 greater than or equal to 3? Yeah, 4 is greater than 3. 5 would work. Heck, anything way out here, we could do 100. 100 is greater than or equal to 3. So anything on this shading indicates a number greater than or equal to 3. Okay, let's look at our next one. X greater than 3 means all numbers that are greater than 3. We can represent this on a number line. We sure can. So let's go to this number, 3. And I always start with an open circle. And then I have to ask myself, am I including the 3? Do I want to color that 3 in? Doesn't say equal to 3. It just says bigger. All numbers bigger than 3. So I'm going to leave him open and shade to the right. These are all the numbers bigger than 3. Okay? So we're not including the 3, because if we did, it would be 3 is greater than 3, and that's just not true. 3 is not greater than 3. They're equal. So that's a no-go, and that's why I have him unincluded. But as soon as I get to 3.1, 3.1 is greater than 3. Yep. 4 is greater than 3. 5 is greater than 3. 100 is greater than 3. Anything up this road is greater than 3. Okay. Next, example 3. We have x is less than or equal to negative 2. Means all numbers that are less than or equal to negative 2. We can represent this on a number line. Okay, so let's go to this negative 2. Here it is, negative 2. Open up that circle. Now the question is, do we want to fill it in? All numbers less than or equal to negative 2. I think we'll fill that in. When the equal to is there, we want to include it. And then we want to go less than. That would be back here. So anything on this shaded part going left, any number back here, negative 2, negative 3, negative 4, negative 5, negative 1,000, negative, anything behind negative 2 is going to make this inequality true. Okay? And the last one, what if we just have x is less than negative 2? That means all numbers less than negative 2. So we would go to negative 2 again. This time we would not fill it in. And we would shade less than. Okay, so hopefully what you're realizing is for these symbols, let me go back to this symbol sheet here. So when it's just less than, it's an open circle. And when it's just greater than, we're using an open circle. When it's less than or equal to, we use a closed circle. And greater than or equal to, we use a closed circle. Okay. And our last page here, coming to the end of this video, we've got some language, lots of language with inequalities. So here it says, each inequality symbol can be represented with different key words. So I want you to look at this first one. Cover this up too. Okay. So we know that this is a greater than or equal to symbol. So we can say greater than or equal to. But another phrase that can go with this is this phrase, at least. If you say to somebody, I need at least, okay, I need at least $20 to go to the movies. What are you really saying? I need at least $20 to go to the movies. You're really saying you need $20 or more. Like you don't want $15 when you say I need at least 20. You want 20 or 21 or 22 or 30. You want 20 or more. So the way that we would represent that in an inequality is M, money, must be greater than or equal to 20. And it's a little funny because a lot of people see the word least and they think less. But when you put that at in front of it, at least changes it to greater than or equal to 20. The reason we put equal to is because $20 is at least 20. Like you're riding the line there, but it is at least 20. Okay, next. What if it's just greater than? no equal to, just greater than. Well, the words that can go with that are more than. I need more than $20 to go to the movies. You don't want 20. That's why I take the equal to off. You want your money to be greater than 20. Even if it's $20.25, that would suit it, but not 20. More than 20, no equal to. Next, we have less than or equal to. Less than or equal to goes with the words at most. At most. I am at most 48 years old. So my A, I put A for age. My age is less than or equal to 48 because that's my top. I'm at most 48. I'm not over 48, at most. So I could be equal to 48 or I could be less. My age is less than or equal to 48. And finally, less than. Well, it goes with the symbol less than, less than, less than. If I say I am less than 48 years old, then it's just less than. It's not equal to. If I'm less than 48, then I'm not exactly 48. So those are some phrases for inequalities to memorize. And finally, our last example, example 5, we're going to solve the inequality and then graph the solution on a number line. Okay, so if you look here, we have x plus 4 is less than 7. Now, solving an inequality is pretty much exactly the same as solving an equation like we've already done. So you take a vertical line through that less than symbol, and we want to get x alone. So what is the opposite operation of adding 4? Subtracting 4, both sides. And that drops these to 0. 4 minus 4 cancels to 0. X floats down. Less than floats down. And 7 minus 4 is 3. So all the numbers less than 3 are going to make this true. How do we graph that? Well, we go to 3. We open a circle. We keep it opened because it doesn't have the equal to on it. And we shade left, less than. All numbers less than 3. Now here's what's cool. What this means is any number we pick in this region or beyond should make the original inequality true. Let's try it. So if I take like 2, right? 2's in that region. So if I fill a 2 in here, 2 plus 4 should be less than 7. Let's see if it is. 2 plus 4 is 6. Is 6 less than 7? Yeah. How about if I choose 1? 1 plus 4. 1 plus 4 less than 7. 1 plus 4 is 5. Is 5 less than 7? Yeah. So anything. Now, the reason I can't pick 3, check it out. If I would put a 3 in here, 3 plus 4 is 7. 7 is not less than 7. They're equal, but they're not less. So that's why I do not include the 3 in my picture. Not 3, but anything less is going to make that inequality true. Okay, so lots coming at you here. Some language, open dots, closed dots, shading, more language. Thanks for watching. Good luck on your practice and happy trails to you.